Okay, today we're going to work on the actual update of the actual calibration for the... Hang on a second, let me shut something down here real quick. Sorry about that. So essentially right now what we're going to do is we're going to set this up so that we can calibrate the actual extruder. So to do that we need filament. So what I'm going to do, because this is an ender, it's kind of simple. All you have to do is pull this blue tab right here, push in this right here, and then pull this out, because we don't need that at the moment. Next we need to take filament, and this filament is kind of bad in that it snaps, but what you can do is you can keep moving it until it gets to a point where it's somewhat gummy, and then you can take the actual clippers and clip it. So now that we have that done, we're going to slide it through the actual extruder. Now this extruder I just installed, so hopefully this isn't going to be hard to do, but essentially you have to slide it through and feed it out. And it has to be straight, so normally when I do this I'm actually over the printer. So let's see if I can get this nice and straight as things start to fall down during the stream. There we go. So let's try this again. Gotta find the hole. Normally if you can just turn it a little, you can get it in there, but apparently I'm having issues, so I'm going to do this somewhat backwards. I'm going to pull out about that much, and this is just so we can see the actual calibration. So let me stick this in here, see how long this is real quick. So I'll take a ruler to it, but that's over 100 millimeters I think. So we'll feed it in the opposite direction just so we can get it in here. Hopefully it'll go out the other side, which it did. So I'm going to pull it out about that long. And I'm going to take a marker to it just to make this easier. So I got to find one that actually shows up. So I have a gold marker that I just have to find. So give me a second to pull that. And essentially the marker is going to be used to mark the distance that's traveling. So here we go. So I'm going to take this gold marker and I'm going to mark right at the beginning so we know where we're starting. And because we're using the printer with its normal settings, I'm going to have to, let me move this out of the way because this is the extruder that I replaced. Let me slide this back. I'm going to plug it in to power it up. So that's the first thing. Now I'm going to actually add power to it. Okay. Now we're going to have to go over to Pronterface. So give me a second to get that set up here real quick. So 2 seconds here. I'll transition over. So in Pronterface we're going to connect. And we're going to raise the print head up a little just to make sure that it's not on the surface. And in order to actually extrude, we need to use the G code. So hopefully I can show you this. I just got to see if I can find it. So let's go over to the regular desktop here. Okay, you can see it. So I'm going to look for the G code M302, press enter. And this is cold extrusion. So this is so we can set it up so we can do it. So it's our first extruder, and then S is the actual temperature. So let's type that into Pronterface. So it's going to be M302, and then it's going to be P0 because we only have one extruder, and then S is the temperature, and we're going to say that it is 0 degrees and hit enter. Hopefully this works. Now we should be able to extrude. So we're gonna have to go over here, and as you can see it's set to 50. So I'm gonna change this to 5 for a second. Then I'm gonna say extrude just to see if it works. So let's switch over to the other screen so you can see what's happening. Okay, let's try extrude. So it is working. So we're gonna go in reverse in a second, just to get it back to where it started. Now we're gonna say that we're gonna extrude 100 millimeters. So everything on this printer, in most printers, is in millimeters. So let's do an extrude and see what we get, and then we'll mark it and cut it. So this may take a moment to actually extrude, but the point of doing this exercise is so that you can calibrate how much extrusion is taking place on your actual printer. So it's kind of a dull activity in that you have to wait for this to occur, but once it's complete, we can do other things. So this hopefully will mark again with the marker as soon as it finishes. So currently it looks like it's still extruding, and it's moving really slow, which is okay. Currently it will change when you're printing, obviously, but as you can see it's moving pretty good. You can hear it actually moving over here. Obviously if I put a line on it that you can see it actually moving, it might be helpful. So it looks like it may have stopped, but there's the mark, we'll say, for now. You probably can't see it very well, but there's a little black mark there. So I'm going to mark this off, and then I'm going to extrude 5 and cut it now that it's marked. So I'll go back over to Pronterface real quick. I'll say that it's 5, and then I'll hit the extrude button. And this is just so we can get the material in the right place. And the reason that I'm doing this, just so you know, is because when I calibrated this printer, that's more than 5. That's awesome. So I guess I'm doing another 100, but we don't need to do that. So I'm just going to cut it right here. So as you can see, I've got to trim that a little bit, but we'll measure this in just a second. So I'm going to cut off the piece right here, and then over here I'm going to do the same. Then I'm going to take a ruler and measure it. So you're going to have to straighten this out probably. So try and get it as straight as humanly possible. And then I'll show you inside Pronterface how we'll deal with it. So now I'm grabbing a ruler, and essentially I want to set this to the millimeter side of my ruler, because if you're not in Europe, we also have inches. So that looks like it's about 96 millimeters. So that is not 100. So what we're going to have to do, I'm going to hit reverse on this just so we can set this back. And while that's occurring, what we'll do is we'll go to Pronterface over here, and the G code to see the settings is M503. Hopefully we can see this while it's still working, but let's give it a second and see. Okay, so it did work. Currently in this configuration, I do have in Marlin the configuration for EEPROM configured, but here's the setting for your actual extrusion. So I'm going to copy this. Then we're going to go over to Notepad, let's say. Let me open this up. It's going to take a second. Let me create a new screen here. And we're going to say what the values are. And I'll explain them real quick. So the first value that you see is your X, which is 80 millimeters. Your Y, which is 80 millimeters. And then you have your Z, which is 400, or Z axis. And then you have your E steps, which is 93. So what we got from this was, currently we're at 93. What we got when we actually extruded, being actual, was 96 for millimeters. So we need to open a calculator up. And it's been a while since I've done this, so let's see what happens. So over here, I think it's expected divided by actual, or actual divided by expected. I can't remember, but let's try it. It's 96 divided by 93 equals, and that's our new value. So then we're going to multiply this by 100 to give our new actual value. So our new actual value is probably this right here, so let's copy that. Then we'll go over here and we'll change this value right here to 93 to the value we copied, and we'll round this up to 23 because there was a 5 after it, and that's our new value. So we'll copy this whole command again, and this is the same process of what you would do for your calibration cube. Normally I print a 20 millimeter calibration cube, and then what I do is I multiply by 5 after I've measured it. So it's going to be like 19.9. You multiply that by 5, then you do the division into that value by 80 multiplied by 100, and that's your new value. So now that we've got that figured out, let's go back over to Pronterface, and we're going to paste that command back in. So you can see that it's M92, X80, Y80, then you have Z, which is 400, and then you have E, which is 103.23. So we're going to hit enter, and then we have to save that value, and I think that is M500, but we're going to have to check to make sure. So let me click right here for a second and delete this command. If delete works. There we go. So M500. Let's double check the command though. So we're going to have to go back over to the browser. Let me find it over here. So we're going to have to search for M500, I believe, which is located, you can't see it very well, so let me change this so you can see it better. So right here we have save settings. You also have your restore settings, your factory reset, your report settings, which is what M503 was. So it's M500 that we'll use to save it. That way, after you've power cycled the machine in EEPROM, you'll have your memory stored. So let's bring up Pronterface real quick here. Sorry, it's going to take a second. And let me hit send. And it looks like it said it stored it. So it's a really weird response. I'm not used to this on this particular board. This is a Creality board. So it does say that there's a cyclical redundancy check of 139 and the bytes are 683. So possibly it's saved, but we can do an M503 to verify. And we can see that our current setting is 103.23. So let's power cycle the machine real quick. So I'm going to power this down. We'll lose connectivity for a second when I disconnect this. Then I'll reconnect this, power back on the machine. We'll reconnect inside Pronterface, and we'll do an M503. So as you can see, it has not changed. So the next thing that we want to do is we want to advance the actual length a little bit here. So let's try doing 5 again, and then we'll do extrude, and then we'll mark it and cut it like we did before if it actually extrudes. And it won't because it's cold extrusion, so we have to do M302 S0, and S0 is the temperature. So let's do this again. We'll try the extrude and see if it works. So it's extruding. So it extruded 5, so I'm going to mark it with the pen. And now we'll do 100, and then we'll mark it and cut it, and hopefully we'll be perfect. So let's do an extrude. And hopefully what we'll see is actually 100 millimeters versus the 96 that we saw. Now if I did the division backwards, it might be shorter, but I think it's going to actually be pretty close. So obviously it's going to take a few moments. Let me look at questions if there are any in the chat. Give me a second to actually find it. Sorry about this, guys. There we go. Looks like there's no questions in the chat at the moment. That's fine. For anybody that's doing super chats or anything like that, or PayPal, thank you very much. It's greatly appreciated. It kind of offsets the expense of doing these. So let's go back over to the printer and see what's going on here. So it looks like it's just finished, because I hear it stopped. So I'm going to take the marker and I'm going to mark it again, and then I'm going to extrude a little bit, being 5 millimeters this time instead of a ton. So 5, and then extrude, and then we'll cut it. Okay. So we're going to trim it again like we did before. Hopefully we're pretty close. That's the first one. Make sure it's as good as it gets. Sorry, I've got to line this up. Okay, and let's do the other side. Okay, let's try and measure this again. So we're going to straighten it out. We're going to take out the ruler. We're going to align it. And now it's too long. So the question is, why are we now at 100 and... looks like, let me see if this is bent. Yeah, it looks like we're at 111. So something went wrong in the actual configuration, which is okay. This happens. So what we can do is we can recal or we can cheat. So I'm going to do M503. And we know the original value was, I think, 92. Whoops, I did the wrong one. So I just loaded default settings. So let's see what we get for M503, because I did an M502. So it did go back to default settings, so it was actually 93. So we know what the old value is and the new value because we kept it in Notepad. So let's compare the two, and we know it's halfway in between. Normally this is not the way you do it. So, whoops, it looks like the buffer was still holding the other one, so let's do that again. But now you know how to reset it back to default. So let's copy this. So we'll right click, copy, and we'll paste it over this one. Normally this should come out to exactly the right number. but we're at 110 right here. So let me put the value that we got. It was 111, I think. Hang on, let me grab the... Now, these values being off by a couple millimeters is okay, but let's see what we got. Yeah, it looks like I'm 116. No, I'm sorry, it's 106. Okay, so 106. New actual. Now this could also be a product of their steppers as I change my settings here. Let me turn the camera back on for a sec. Sorry, I gotta reach up and feel around. There we go. So actual is 106. So between these two values, we have a halfway point. So technically we could make this an even 100 or maybe 97 as another way to estimate where we are. And hopefully that'll be close because originally it was 93. So maybe, well, that's about halfway. So we could actually paste this in. We got to do it anyways. So let's go back over here, paste that command, hit enter. It's already been accepted. So now we're going to do M500 to save it. And hopefully we got it right. So let's do an M503. So it's now 97. We don't have to reboot the machine to test this. Maybe we have enough material to do this. So let me mark it real quick here. Now obviously the way I'm marking it may cause error the way I'm doing it. Normally you cut it flush, but let's do another extrude of 100 real quick. And see what we get. That way we don't have to reboot to check all these values. And I'll check for questions in the chat while that's going on. Well, you guys are awfully quiet today, so we'll stick to the actual calibration. It's been years since I've actually done this on a printer, at least at home. So this is just step one to calibration. Next we'll actually do prints. So I did level the surface and then re-level it after I changed the springs. So the new springs are actually somewhat more stronger, we'll say. So that might cause some calibration issues. The older springs are actually these. So there's a slight difference in size, I think, for length. It's very hard to perceive. But what I'm going to do is I'm actually going to cut this flush. Maybe this will help. Okay. Then I'm going to cut off the other side. Right there. And we'll try this. And hopefully this will be the last time we have to do this. Otherwise, if it's pretty close, we'll leave it. Because it's not perceivable. But it looks like we're almost dead on. That was just me estimating. So, yeah, it's about 101, which is better than, whoop, I'm sorry, it's almost 100. Sorry. So it's better than it was for 93 millimeters. So that's now calibrated. So let's see if we can move on to the next stage. So I'm going to have to remove this material. So apparently I'm at the very end of it. So I'm going to see if I can back it out. There we go. So now I can do this and just yank it. So we're done there. Now what we'll try and do is calibration squares. Now I placed up on Patreon the formula to do this in OpenSCAD. So I'll pull that up in a second to show you. So OpenSCAD, I still have it open. Let me just make this a little smaller so you can see the image. I'll move it over here. So essentially, we're going to do squares. So we're going to have to go through some steps to set it up. And I'm waiting for this motor to finish and hopefully slide this through. Okay, it just stopped. So obviously me doing this from here is a little bit harder as I knock the stuff down trying to do this. There we go. There we go, I got it through. So now you can take this and you can slide it over here, push it in, and you have your material, so you can slide this all the way down. Now there might be another problem with this printer because this is the one I've been rehabbing. There's a little kink in here. So if I can get past that, we can use it. Otherwise, you're going to learn how to replace one. There we go. So I was able to get past it and down into the print head. So I don't know if you can see this very well. Let me see if I can bring another camera to bear on this. Give me a second to see if I can pull it open. I may have to focus this one for you so you can see. But there's a little problem in this printer. And I'm doing the camera work by hand, so this is going to be interesting. Okay, so lighting on this camera is terrible. So let me see if I can fix it. If it's on. Hang on. Well, looks like this camera just needs to be well, that camera's useless. Anyways, there's a little kink right here. So let's move on. I'm gonna slide back up here and we're gonna go to Pronterface. Inside Pronterface, I already figured out the formula for this. So our bed is 20 millimeters by 220 millimeters by 220 millimeters. So I designed this little pattern right here so that we can actually work with it. So it's going to hopefully print these squares perfectly. Otherwise, we're going to have to adjust the wheels on the printer. So to do this, I need to open up I have to open up the Ultimaker Cura, and I need to export this. So I'm going to go to Export STL. It's going to tell me to re-render, so I'm going to hit F6. Then I'll do it again. So Export STL. This comes up. Bed leveling squares STL, so we'll say Save. And then right about now, Cura hopefully is already opened. So let's open that up. And you can see the actual surface. We're going to improve the quality a little bit on this. We're going to say keep the changes. And I have to go over here and I have to try the export again because this is the way I normally do it when I'm messing around. I'm going to move this over to the other screen. Then I'll go back over to Cura. And I'll drag and drop it in. So I'm looking for the last modified thing. Sorry. Go back over to Cura. pull it in, and now you can see the bed leveling squares. So it may not be perfect, my design, but we'll find out. This might be too far out to the edge, in which case I got to adjust it, but that's in software. So we'll slice it, we'll save it. It's saying that it's only 0 minutes to print this, which is probably not good. So that means I got to go back over and modify this real quick. So essentially, let me hit cancel. Inside here, I'm going to change the height to 0.2, we'll say. Then I'll re-render this after I hit F5. Or excuse me, F6. Now we'll go back over here and we'll say export the STL. Save it, replace it, and we'll see what happens. So let's go over here. We're gonna reload this. We'll slice it again. Hopefully it'll give us a time. It says 8 minutes, so that's good. So we'll save it. It's gonna be a G code. So we're gonna say save, open, and here's where it gets fun with this software. So right here we have it saved. I'm gonna have to minimize this. I'm actually gonna bring it into Pronterface, which I normally don't do. So we'll go to here. Let me find the directory real quick. It's in my documents. So let's go there. There's the actual program. Normally this would be done inside of Pronterface, or excuse me, inside Cura. And apparently that seems a little off. So somehow I made a mistake, or it's my settings. So let's see what we got here. It's been a while since I've used this, so it's going to take a second. So platter, and that's useless. So let's try options. Here we go. So inside options, let's see what the bed size is. Apparently I'm not seeing it, which is awesome. Okay, so bed size isn't here, but it's right here in front of me. Sorry. 220. 220, and on this printer it's normally, I think, 250. That might be another video in the future. So we're gonna probably have to close this and reopen it. So I'm gonna disconnect, close it, close that, hopefully. Lovely. Okay, let me see if I can find it real quick here. Pronterface. Let me open it up again. I have to drag it over. So that might be bigger now, so we'll connect. Then we'll load. Click OK. And that was the issue. So the settings were not good. So to print this, it's kind of obvious it's print. But first thing I need to do is go back over to the printer and fix something. So let's go back over, and I have to do this. This little clip prevents the PTFE from sliding out. So I'm gonna have to put it back in here. So it goes inside this little white piece right here, in between the metal. And there you go. So let's give this a print. Let me see if I can show both at the same time. There we go. So let's click print. Now the default settings, just so you know, inside here, let's see what they are real quick for the actual printer. So if we go over to, let me transition so you can see it. If I go to printer settings, I believe it is, so it's probably right here. I've essentially changed this to an Ender 3. I'm trying to find temperature, so obviously I'm clueless because I didn't type temperature to search. So it's 200 degrees Celsius and the bed temperature is 60. So that's what we're going to be working with. Hopefully we can do that now. So let's do print. And so now it's starting to process. What's occurring is you should see a temperature rise for the bed, which is right over in here. And as soon as that reaches temperature, if it does, then the extruder will turn on next. Otherwise, we'll see an error over here in processing, where it'll say something like 999, where it's failed. And that's usually, almost every time you see it, having to do with a thermistor that's either broken or not attached to your motherboard. So I've answered that question about 8,000 times, just so you know. But let me check questions real quick here. Hopefully there are some. Looks like Ryan's online. And Victor. Basically, I'm giving a very boring tutorial on how to level a print bed. But let's see what we got here. So it looks like we're almost to temp. Another way to check this is here. It's kind of hard to see, but you can see it approaching the actual target bed temperature. So the orange line has the red line coming up and it says bed. The same thing will occur for the extruder being EX0, but it's going to be way up around 200. So essentially I leveled the bed somewhat earlier, so this might be a little bit of a messy video, meaning that I don't know how level it is. And I actually got a new leveling tool other than paper, which I normally use. So today I used cardstock to do it, but normally I use a lottery ticket because it's thinner. And then I wait for the rubbing between the two surfaces when I Z to 0 so that the print head is touching. Now this is already 60 degrees. So we should see that the bed temperature now, yep, just went up for the extruder, excuse me. So that target temperature needs to be reached before it begins to print. And then hopefully it will home. Now all the stuff you're seeing on the right hand side in Pronterface, these are echo busy. There's a command actually in a loop occurring, I believe. And once that's reached, it moves on to the next command. But these are usually filtered out, and you can filter them in Pronterface, but I don't suggest printing in Pronterface. I do suggest printing in Cura, or in either, if you're using Octoprint, that's another good place to work with the printer. That's usually on a Raspberry Pi. That way it offloads some of the cycles on your computer to another computer. So let's see how well this turns out in a minute. It's probably not going to turn out well, but at least you get to see it. And I might make the actual image bigger because what you're seeing in Pronterface is probably not going to give you a good idea of what's occurring. And the camera might blink out because every half an hour it times out on me. So let me make this bigger and show you what's occurring. So essentially any second now, when it reaches temp, there'll be an 8-second countdown and then it'll begin. So it's almost at temp as we speak. Right now it looks like it's 200 degrees Celsius or 2.59 or 200.59. There we go. So what it's going to do first is print a line before it starts to print the actual print. So this primes the actual extruder. So you may not see anything right away because I didn't feed it all the way down in and checked for extrusion. but it's pretty close, so it looks like it's already started. So it's a little loose. So now it's going to print the squares. So over here, you can see that it's a little loose. Here it's a little loose. So I want to turn this to the clockwise position in this case, because if you rotate, counterclockwise, it will bring the surface closer. So I'm going to do that in a bunch of places. Hopefully this will start to stick on the surface. The reason you're seeing it kind of goofy is because I used cardstock instead of a lottery ticket. So if this doesn't adhere, then I'll actually push it down. So it is somewhat close, so I'm going to give that a quarter turn. Probably going to have to give this a quarter turn. Still not good, so a little bit more. There we go. It's almost there, so a little bit more. Same thing over here. Still not there. So let's do all of these. I'm going to brush this off because it's actually not adhering yet. Now, the one problem that you may run into is you get too close to the surface, in which case it doesn't print at all, because it's just going to back up. You'll hear a clicking sound usually up here. So it's still not high enough, so I'll give it another turn. It's still wiggling. Give it a couple turns just to see if I can get it to stick to the surface. It's starting to. So let's do this over here just in case. It's also a new bed, so let's do that. Still too loose. So I'm going to pull this out of the way. The good thing about doing this is eventually you'll get closer. Now it's doing another surface. So the inner surface is not working well either. So it means I'm too close. Over here it's getting pretty good, at least on that. So let's give these a full turn. And you're probably going to have to print these multiple times just to get this to work. And next time I'm using a lottery ticket, because cardstock is the worst. Okay, it's starting to stick. So it shouldn't move when you rub your finger across it, but it also shouldn't be hard to remove from the surface. So at least we got one corner. This one's actually too low because I can feel it. There's no ridge. So I'm going to give this a downward turn, being clockwise. And then we'll check over here. That's a little loose still, so I'll turn that. Over here, it's still a little loose, so I'm going to turn this up. And it's still not there, so give it a little bit more. See what happens in this corner. This is probably the most boring activity that you'll do on your 3D printer. This needs to go down a little because it's too flush to the surface. This one is good now and it's sticking. That's sticking. Let's check over here. Okay, it's loose. So I'm going to double check this one. Okay, that's not bad. So that's pretty good. So as you can see, the whole process is repeating the same thing over and over until you get a better result. So this one obviously is not that good. It may leave a little mark in your surface of material that didn't print, but that's to be expected if it's too close. So let me get this off my table for a second and rub my finger around here. So it feels good there. Everything's good on the inside. As you get out to the edge of the table, it may change and become loose. Depending upon what you're printing, you may have to calibrate it even more. But mostly this bed is what takes care of that issue. So let's feel this. That actually is almost perfect. Okay, this corner isn't moving, that's good. So this corner is still too high, so I'm going to basically move it down by moving it clockwise, so rotating this way. This corner is about right, that feels about right, that feels about right. So it's only this corner now that needs a little bit of work, and you can see the markings that it leaves. But when you do a print, that'll eventually peel off. Or you can take a razor blade and pull it up. So while that's going on, let me check the chat. Yeah, well, if you've done this 100 times, it's boring. I think I've done it more than 100 times, but it also is low on material, this design that I did, so that you're not going to burn through a lot of your filament when you do it. So let me see if there's any more adjustments that need to be done here. So now that's perfect because I got it just low enough. It may throw off other corners when you adjust it depending upon the tension, but it looks like we've been able to manage to control all of it now. So there should be almost like a 0.5 millimeter ridge that you feel on your finger, but it should stick to the surface when you rub your finger across it. Also, this is hot, so be careful. You can crank the temperature actually down to 50 degrees Celsius for the heat bed, but this is at 60 right now, which is, I don't know, about 100 and something. Let me do the calculation real quick here. It's Celsius to Fahrenheit. Celsius to Fahrenheit calculator. Okay. 60 degrees Celsius is 140 degrees Celsius, so it's a little warm. This corner is a little loose, as you can see, so I'm going to move it counterclockwise, and that will dial it in. That corner is pretty good. This one's a little low still, so I can actually crank this down just a bit more, being in this direction, in this as well, and that will give you that ridge. Now it may throw off the center, but we're going to test that with a 20 millimeter calibration cube in a minute if I've got one on hand. Otherwise we'll download one or make one. They're actually super simple to make, but it looks like I've got this nearly perfect. Now this is the rehabbed printer. The printer, when I received it, had a broken belt and had broken feed holders for the bottom underneath here. So I had to replace those, and then the Y-axis for the stepper was also broken. So this printer is going to be going to someone that I work with. They offered to buy it after I got it rehabbed. So I have a second one in queue, and then a third one I just ordered today. So hopefully I can get through another one, and I'll show you the actual updates. So this is done now for the actual surface. It should peel off somewhat easy with just your fingernail, but if it doesn't, then what you can do is you can use a razor blade. So right now my fingernails probably are not long enough, so let me grab a razor blade. So all you have to do is get underneath the corner. You don't want to scar your surface, but it should just peel right off. So I'm not going to do a second one of these, even though it probably needs one to actually calibrate, but we're pretty close, so I'm letting it go. See if I can get this one off, because the corner was a little low. I'm going to do the 20 millimeter cube next, and we'll see if the surface is okay. So hopefully I can get all of this off and make it look like a brand new surface, but there's a little bit of scarring there, but that's okay. And of course, when the person receives the printer, they're probably going to have to watch this video to recalibrate it. So now what we want to do is print a calibration cube in the center. So the calibration cube, if we go over to here, I'm going to start a new, let me see if you can see what I'm doing. Okay, so I'm going to do new inside here, hopefully. There we go. So inside here, we're going to make a calibration cube. So if I hit render right now with F6 or the render down here with the Z, it's not going to show anything. So to make a calibration cube, all you have to do is say cube, open and close paren, then square brackets, then you're going to do 20, 20, 20, then end it with the semicolon, then hit F6 or the Z down here, and as you can see, there's your calibration cube. So let me start my camera again here because it decided to turn off. So now we need to export this, so we're going to go over here and say export STL, and then we'll call it a 20 millimeter cube, and we'll say save. So now we have to go back over to here. I'm just going to say Control A to highlight all. I'm going to then delete this, hopefully, if I'm in the right place. There we go. Now I can hit delete. I'm going to pull in the other STL. So what we'll do is we'll see if we can see it. There's 20 millimeter cube. So we open it and you can see it. So now let's slice it. I'm going to move this up to 20 millimeters for step. This is the number of steps for layers. And I'm going to slice it. This is probably going to take a little bit of time. It says 119 minutes. So let me show you the difference over here. If I were to change this to 0.28, keep the changes, slice it, excuse me, it's 56 minutes. So I'm going to go with 0.2. I know that's excessive. I'm going to save it. Then I'm going to actually import this into the printer. So let's go over to Pronterface. And in Pronterface, we're going to go to load file. There's the G code, open. You can see it's printing an actual line over here to start to prime the print head. Then it's going to print a primer around it to get the print head moving. Then it's going to print the cube. So let's click print. And like I've said before, normally I don't use Pronterface anymore. I either use Cura or I use Octoprint. Currently though, I can't show you Octoprint because I turned off the machine. So let's go back over to the desk camera in a few moments. It should print or heat up quicker because it's already got some heat in there. So you can see that it's already heating. But let me change the view so you can see both at the moment, hopefully. There we go. And then I'll transition over that in a second. Let me check on the chat, see if there's any questions. Doesn't Marlin have live adjust Z command? It may, but currently I'm not working in that. Right now I'm having trouble because there's some kind of heart sitting over your comment, Philip. But essentially what we're going to do is print this calibration cube right here. And I'm going to have to mark it with a marker at the end, probably the gold marker that I was using earlier, so that we know that the top is the Z-axis. The front facing me, being over here, is actually the Z-axis, or excuse me, X-axis here. This is the Y-axis. So I'll mark an X on the front, Z on the top, and then a Y on the other thing so that I know where they are. Then I'll actually measure it with a caliper to actually get the actual measurement, and then we'll calibrate the actual printer for the actual number of steps that we're working with. So any second now it'll start up. Let me grab something to actually wet my whistle with, because my throat's a little cottonmouth. And for those that haven't actually seen this video before, or this live stream before, the previous one to this, I was actually doing pre-flight checks on the printer after I brought it up. Granted, I never changed the motherboard on this, but it was a brand new printer. So I wanted to see if there were any issues with it, and that's what I'm currently doing, is testing it to see if it works. So we might run into an issue where the actual surface is not high enough in the center, and I can show you different ways to deal with that. But let me change this back to the other view. So give me a second here. There we go. So essentially, this area might be shallower. This is a brand new, or excuse me, this is a used printer, but apparently they broke it initially out of the box, meaning this little piece over here of metal was bent and it was snapped. So all I did was replace the broken parts. So we're about to find out if it works. So rub your finger on that. It's a little loose. So we may have to raise the surface a little to get this to actually stick. But let's see what happens with the actual print. I'm guessing this back corner is probably a little low. So far so good. Neither one of us can see it, but we'll see what happens in a moment. So now it's going to be extremely boring if I can't get the other camera working. So let me see if I can work on that so you can see what's occurring. So this might take a second. I've got to actually examine what's going on with this camera. Let's see. Might have been I left it plugged in for a couple days. There we go. Got it working. So let me focus it somewhat. And I'll see if I can get this so I can see. I'm gonna have to hold it with my hand. Okay, I'm gonna show you in just a second. You're probably not gonna see much. So right now, it's just printing the actual surface for it. It's a really horrible image. Okay, this probably is not the best way to show it to you. But essentially it looks like it's adhering to the surface in its printing. There might be something going on with the slight to the left of that. But let me put this back where it was. Sorry, you're seeing more of my kitchen than I want you to see. Well, I'm just going to put this down for now. See if we can do this. I don't want to put this on the surface, but obviously I got so many things moving in my arms next to it. So essentially this is going to run for a bit, and then once it's complete, we'll take it off the printer after it cools down, we'll say, or you can pull it when it's hot, but you want to let the actual filament in the actual cube cool down enough that the sizing won't change, because it might shrink 20%. If it does shrink 20% on the actual printer, meaning the filament, then you may adjust according to what you need to do. So filament does have the ability to shrink, I'm sorry, between 5 and 10%, not 20%, sorry. But let me check the chat, because someone's probably correcting me as I speak. Actually, the X belt currently is pretty good as far as I know. It's going to flex when it moves, but I can adjust it with the 2 screws here. But you can see that when it's usually not working, meaning you're not printing, you can adjust it. But yeah, I can see there's a little bit of rise here, so it could be loose. But there's a little bit of control over here that has the gears. This side doesn't. So you can see it popping up and down. So that's another thing you can do. You can take the 2 screws here and then extend this over. There might be 2 more on the other side. I don't know. I know there's 4 total here, but on this I have to examine it. But maybe I can show you guys how to make a belt sometime. I'll probably make a very short video on how to do it. But essentially it's just crimping on these metal clasps. And it's kind of like making a DuPont connection. Let's see what we got here. Yeah, there may be issues with the X-axis. It looks a little thin, but we'll be able to tell that with the caliper. It's probably going to take about an hour for this to print. Let's check on the time. Currently there's no countdown in here for Pronterface, so it's kind of useless to watch it. Oh, actually there is in Pronterface. I forgot where it was. Let me show you real quick. So in Pronterface, obviously it's covered right now, but down here where the video is playing, underneath, inside Pronterface, let me see if I can move this over. You'll see there's a countdown clock right here. So let's just put this up here for now. And essentially, you guys can watch the countdown. I'll be back in a second. I gotta go pay the water bill. If you guys don't know what that is, I can't help you. But we'll give this some time to run. Almost wish I printed something bigger just so you guys could see it. But let me see if I can try the other camera again. Maybe it'll be better. At the moment, probably the filament color I'm printing is not good. Also, the lighting's a little off. Let me see if I can find a different light here so that I can show you, but you can start to see it. Now, this printer was really cheap. It was a used printer that I found on eBay, but I'll be printing partsless of all the parts that I have to replace on the printer when I work on it. For instance, there's the springs. Let me jump over to the other camera here. So I changed the springs like I said earlier. I also changed the extruder. The motor that came with it probably is still good, but I wanted to put something that was metal because the plastic on these wears out after about a couple of months of printing. So I just swap it right away. But that's just my habit because I've gone through it so many times. And the other thing I did is I added an actual surface to it because it was metal underneath. And then it has a surface that you actually put on with clips. I prefer the actual magnetic surface because it's easier to work with. But you can't see anything I'm saying right now, so I'll do it again. Here's the actual old motor for the stepper. So I took this out. This is actually either welded on or Loctited on. I couldn't get it off, and there's no screw holes in it. It's probably perfectly fine, but the actual metal that comes with this one is actually better because it won't wear out, and I'll show you what it looks like. This is the actual package that comes with it. Obviously the light's terrible, but you can see that it's about $10. It's a good upgrade. The springs are about, I think it's $2.50 for 12. So it's about 50 cents a spring, but these are better springs than the other ones, and I'll show you the difference real quick. So if I take out one of these, the actual spring constant is better when you squeeze it. This has more spring in it, being the yellow ones. These silver ones, they're okay to work with. They'll last about a year, maybe 2, but these will last a lot longer. So for 50 cents a spring, and there's 4 springs, it's a good deal. The other thing that you may have to do is replace your print head. When you do replace the print head, normally what I do is I detach the actual heating element and also the thermistor, and then drop in a new one with it detached as well, and then screw it back in. That way I don't have to wire it all the way back down into the motherboard, which is a little bit of work. So it's 5 minutes versus an hour. So we're getting pretty close to, looks like about, well, actually we can check. If we go over to the desktop, over here you can see what the height is down here. Now I'll have to read it off, but it's almost 5 millimeters. So that's pretty good. You can watch the steps as it goes between layers. Now it's 4.4 millimeters instead of 4.2. But I'm trying to do an even number because in case there's something wrong, it won't be off when it steps. So we've got probably another Well, the countdown says that there's an estimated hour and 10 minutes left. So there's not much we can do for the next hour and 10 minutes except wait and watch. But you can see in Pronterface, green is what's printed, red is what is not finished printing yet. So there's a lot to this, but you can see what's occurring. But I'm probably going to do at least 2 more printers to see how the upgrades go. And then I'll make a video on the experience, but I'm guessing that most of the time the experience will be good. The very first printer I got, I did not have a good experience with. Let me see if I can show you the part. So here's the actual part I had to replace. I tried to straighten it. It was bent about 30 degrees. I couldn't get it perfect. If I used other tools, I would be able to make this perfect. But let me see if I can change to the camera so you can actually see what I'm talking about. Here's the actual part that was defective. It was bent about 30 degrees. I was able to put it in a vise and try and straighten it. It's nearly straight, but I figured because it's already been bent, it's not going to be useful. So there might be hammer marks on it someplace, or this is not the actual part that I'm actually referring to. So let me grab it. Here it is. So this is the actual part. You can see there's actual hammer marks on it because I got frustrated and tried to straighten it that way. But it's not perfect. I did find alternative parts that are similar. So essentially, these were ones I found online for about $4 plus shipping. The actual part that I replaced it with was the actual factory part, which was $4 plus $10 shipping. The other ones are significantly cheaper for shipping, and I ordered 4 of them just in case. But essentially it's the same concept. The holes nearly line up on it, so it's basically the same thing. So I probably never will need to worry about that again. I also had to order screws to actually work on this. So one of the screws was actually missing, so I was able to find it on Amazon for the back, and then I had to get washers, so I bought 100 of each just in case in the future, in case I do more of these printers. But you can take this printer, it's about $80 with shipping, and you can turn around and probably sell it for $150 after you upgrade it. Now, I didn't do the full upgrade. I didn't do the actual controller board or motherboard. It's usually called the MCU. The reason I didn't do that is because that's another like $30, $40. So this cost me about $120 to bring back to life. The second printer is probably going to cost me significantly less because I know what I'm doing now. But as you can see, it's turning out pretty good. The printer is pretty solid. You can actually peel this back and take it off. Let me check the chat, see if there's any questions, because I know you can't see the print very well. Well, looks like we got a bunch of questions in here. Let's see, I think your X belt is loose. Yeah, we talked about that. Let's see. Mine is running now. No movement, fast or slow movement on the belt. I'm in the middle of a print. Let's see. Somebody else said nice. Then we have the belt doesn't look like it's loose. It possibly might not be loose. It might just be flexing. Let's see. Had a bad X stepper last night. No matter. Tons of noise. Yeah, this printer, currently the reason that you're hearing so much noise has to do with the steppers in the default motherboard. So the Creality motherboard, I think, has A4988s. I could be off on that. But essentially it's a very noisy stepper. If you change the motherboard to something with a TMC 2209, then the actual noise will be almost minimal. The only thing you'll hear are fans on the actual printer. Now, I got a bunch of tutorials on how to work with the actual steppers, and I do have other boards that I can swap in, but I've been somewhat lazy. Let me see if I can find one real quick. Don't know if I have any close by. Let me see if I've got one here someplace. Here we go. So I could probably stick in this SKR Pico. Let me see what it's got on it. So the Pico, I'm not sure if this is going to work in this board. Yeah, this one is probably not going to be that good. I think this one has only 3 steppers, but I have to examine it closely. No, it has 4. So essentially this board you could drop in, and it's got a heat sink built in, and I think it's TMC 2209s, but I need to look up the actual data sheet. But on here it says that it has XYZ, and then it has E, so that's 4 steppers, and then it's got multiple pins. So I might do that as a video as well. And I think, let's see, it's got thermal hot end, and it's also got the bed, and then it's got all the other stuff. But working with this board is slightly different, so I'm probably not going to do a lot of videos on it. It's just one of those ones I saw online and bought it. I have a lot of videos that I don't do. Hang on, I think the camera just went out, so let me start it again. There we go. Here it comes. It's going to be back on in a second. Obviously, when I'm watching the actual video occur from my side, there's probably about a 10-second delay. So what you're seeing and what I'm talking about are delayed by several seconds. I don't know if that's something they do on YouTube automatically, but I'll eventually show you other updates on this board. Apparently I've got way too many of these floating around. Let's see what we got for comments here. Let's see. Also, loose steps when using slow acceleration speed, I think is what you're trying to say. I have a question for you. Why 8-bit MCU AT Mega 2560 loses steps with Clipper? I actually use more modern boards in most of my printers. So essentially I'm using something like an SKR4, or excuse me, SKR2, or I'm using a what is it, SKR 1.2 Pro. But I've got lots of different boards, obviously, because as you can see I have a huge playlist of information. But normally, if the Ender is working for the 8-bit processor, I'll just leave it. It's when it starts to get really weird, then I'll replace the actual motherboard. So if I see shifting and it's not the belts after I tighten them, then what I'll do is I'll change the motherboard, because it means the stepper is overheating and losing steps. Let's see. Mine could use 2 rooms away. Yeah, with the different steppers, if you put in the TMC 2209s on the modern actual motherboards, you won't be able to hear your printer except for the fans, so it's very quiet. So the newer Creality board, I usually don't work with them, but I think the 4.2.7 is 32-bit, which means that it's probably got quieter steppers, like the TMC 2209s. I actually think I have one of those boards that I ordered just to experiment. Excuse me. Let me see if I can find it real quick here. It might still be in its box someplace. Sometimes they don't label their boxes. It's not it. That's a 1.4.4. That's not it. Sorry, it's someplace in this room, hopefully. I have this habit of putting it back in the drawers. I'll probably show you guys how to update those later. But I usually don't stick a Creality in it after I've updated it. I usually go with a Big Tree Tech board just because it's more reliable. But different people have different takes on it, so that's up to you. Let's see if I can find one. Apparently I can't find the board, so I'll have to search for that later because it's probably buried in the other room. Because I have probably a catalog of like 50 different boards. Let's see. The E3 Mini is probably a more reliable board as well. This one I think is a drop-in replacement. So this is an E3 board. Looks a little bigger. The actual slotting is the same for the actual configuration. And I'll show you what I mean. Here's the default Creality board, and here's the actual Big Tree Tech. So you got the heat sink for your steppers right here. You got your steppers over here. You can see that the stepper on this is very tiny. So I'm guessing if I take a magnifying glass, I could see what type of stepper it is. These I think are TMC 2209s. But I have to examine the board closely. It might be their 2208s, but they're very similar steppers. It's just one has sensorless homing, one does not. So I think this one might have sensorless homing. I have to stare at the board for a second to see if I can find the settings. So yeah, this one probably has TMC 2209s on it because it has the actual jumpers for X, Y, and Z for sensorless homing. And what I mean by sensorless homing is the end stop is over here. You don't need that with sensorless homing. And if you have it connected and you set up sensorless homing, you'll fry your board, just so you know. Not that I've done it. Let me see if I've got that board someplace around here. Now, SKR3s. Yeah, I'll have to search for it because I currently don't have it. But I will be doing some interesting tutorials on this printer for a while, just so I can get people into this. It's a very cheap hobby when it comes to getting printers. But it's more expensive once you start upgrading and doing strange things. But let me try changing the camera so you can see where we are here. So here's the camera. Let me transition over. So hopefully you can see something. The light is terrible, but there it is. So if we were to go over to Pronterface, let me change over here. you can see we're almost at the halfway point. So it's looking like this is going to be another hour or so just to get there, but the time says 49 minutes more. But whoever's doing the super chats, thanks. That's greatly appreciated. Or what? I think someone's doing either Patreon or they're doing PayPal because it's popping up on my phone. Yeah, it's TMC 2208s. The reason they do that on the 4.2.7 is probably to help you avoid cooking your end stops if you were to do sensorless homing. The processor on that is pretty slow, whereas the processor for SKRs is somewhat stronger in the number of megahertz. So I think, let me check real quick. I have to actually pull up the website and I'll show you. It's just going to take me a second to find an actual page that I can bring up to show you. There we go. Let me go to the Big Tree Tech website real quick here and then I'll bring it up for you. Okay, so on the Big Tree Tech website, let's make this so you can see better. They have a bunch of different boards. The SKR Mini E3, that would be like a drop-in replacement. If you were to open it up, they will tell you the megahertz, but I think it's in the manual. And I don't know how well this manual is going to open. I think that's the manual. They're not being real clear in their documentation, apparently. Let's see if I can find it. Here it is. No, that's not it. This might be why I don't do a lot of videos on this board, because they don't document it. So, let's try the 3.0. That's Marlin, README, Clipper. That doesn't tell us anything. Lovely. Let's go back. Hardware. Let's pick this one. Of course there's no manual. Lovely. Let's see what this is. Sometimes their documentation's horrible. Well, that's not showing us anything, so we'll find a different actual device. So if you go to repositories and then you type SKR, they should have the version 2. Inside here, if you go to, I think it's hardware, there's the manual. This is probably why I showed this one a lot when I did videos on it. This one's got 168 megahertz clock versus, and it's 32-bit. And you can drop in whatever type of stepper you want and set sensorless homing. So it's a really nice board in that respect. It's also rather cheap. But let's see if I can find a different board here for SKR. The SKR 3 has been out for a while. Some people don't like it, so I don't talk about it too much anymore. But let's see what the actual speed on this is. This is the EZ, so it's different steppers. Some people don't like these. They have another version that's non-EZ that uses the steppers similar to an SKR2. But let's see if we can find the stats on this board. The way they do this for PDFs is not fun. So it's 480 megahertz per second, or clock cycle, excuse me. So 480 million operations. It's 32-bit and it's an STM32H743. So it's a really nice processor. Can do other things, but I don't want to go into that too in depth. The other popular board that I do a lot of videos on is the Octopus. This is an advanced board though. So let's go with the Octopus Pro. Let's pull up the manual here real quick. This one, the speed of the processor is 180 megahertz, so not that fast, but look at all those pins. It's just crazy. So this has a slightly bigger MCU, but a lot of people like it. So let's go back to the desk camera and I'll double check to see what's going on in the chat. Yeah, the SKR3 is very capable. There are issues with the first ones that came out. Unfortunately, I had one of those where it cooks your board if you set it up. They've since then fixed it, so that's no longer an issue. But that was a long time ago. Let's see, adjust the current on the trim pods. Yeah, you can adjust the actual current on the trim pods to make it step more quietly and also less heat. It's mostly for the heat, but I don't suggest doing that on a Creality board, but I've shown how to do it on other boards. I think the last board I showed how to do that was the Ramps board. I made some tutorials on how to do the actual adjustments for TMC 2208s and 2209s and anything TMC. You can adjust it in software, so that's why I don't show that anymore. Let's see. Yeah, I've made Octopus Pro videos. I made a lot of those. Also did Octopus Pro 1.2. I don't know if there's any new boards coming out recently, but one of the ways you can check is go to the Big Tree Tech GitHub. Let me see if I can swap over here so you can see. So on the Big Tree Tech GitHub page, if you want to see if something new is coming, sometimes what you can do is you can look around and see if they've created something new in their repositories. Looks like 2024 they haven't done much. 2023, it looks like they have a lot of commits. So I guess the Big Tree Tech Kraken, I believe that's an extruder. Let's see what we got here. We click on the manual, or it might be a board that's just renamed. Okay, so this is a board with 1, 2, 3, 4, 5, 6, 7, 8 steppers. It's like an Octopus, except they're hiding your steppers. I think they're probably like TMC 2209s. That's the most common one that they do when they do surface mount. So you can't change your steppers. Then it's got other pins, obviously, for looks like X, Y, and Z all the way up to 8 end stops. There's a probe for BL Touch. You got two connections for your display if you want to use the older displays. Also, you can use the newer display, I think, on here. Yeah, it looks like the pins might be there. Or you can fool it by putting in pins yourself, meaning that you'll change the actual pinouts in Marlin. But that's more advanced stuff, so I'm going to try and avoid it right now. But it looks like there's RGB on this. I haven't bought one yet. I'll probably get around to doing it someday, but usually when it's got surface mount parts for steppers, I avoid it because there's not much to talk about. About 30-40% of my videos have to do with steppers, so that's why I don't usually do these. But there are other pins on here. I've not had a lot of good luck with the actual RGB. That might have to do with cabling. But let's go back over to the camera and I'll double check the chat. Let's see. Yeah, I have not 2 printers, but let's just say I've got a habit with printers. Currently in my apartment, I think there's 5 Ender 3s, and 2 of them will be going out the door to people I know. And then the other three, one of them's a upgrade Ender 3 that I showed how to do the SKR, and I think also the MakerBase upgrade board on that. But most of the time I use Ender 3s now. I used to build printers, so I've got about 6 of those all around the place. They're more like sculptures now because I don't use them anymore. But eventually I'm going to build a bigger printer. It's just having the time to sit down and work on it. Yeah, there's surface mounted TMC type steppers, I believe, for the Creality. But I have to look at the board and actually read the chip, and they usually cover it, so it's hard to do. So I have to go and find the actual pinout diagram or the actual data sheet. And Creality is not the best with data sheets. That's why I don't do a lot of stuff on Creality. But Big Tree Tech is very good with data sheets most of the time, like 95% of the time. So that's why I usually go to their site and look these things up. But I'm going to check to see if the Kraken's available in the US. This was over the holidays I checked last time. It's BTT Kraken. Yeah, it's $129, so I personally think that's overpriced. Other people may not. But it looks like it's got TMC 2160s built in, which I believe are higher voltage steppers. You can also do them as plugins. I think I might have one I haven't done a video on because Marlin has not yet upgraded the actual firmware so that you can work with it easily. And there's also another issue with the 2160s where they put it either in UART or SPI, so you have to know which one it's in before you do it. Otherwise, it's not going to work. So that's why I avoid doing the tutorial on it at the moment. Let's see. Looks like Marlin has yet to upgrade the actual... Let me show you what I'm talking about. There's another version of Marlin eventually coming. I thought it was going to come at the end of the year, but it didn't. So right now we still have the one from last year. Now, if you want to see what the new stuff is, they do have the bug fix. But remember, when it says bug fix, that means that they're fixing bugs. So it's not stable. Meaning current release is stable. These are not. So what you can do is you can go to download configuration, and you can actually see what they're doing. So if you go to repositories, you can go to Marlin, and then there's a drop down here. Currently that's bug fix. The release versions are going to be tagged builds. So this is the last one that was released. Bug fix is more current, which is this. This is where they check in their changes, and you can see what's actually here. So there is stuff I want to cover. It's still not in the actual regular release, but if you go to core boards.h, these are all the new functionality that they've actually added. So you can go through and find if there's a board on the market, it's probably in here. If not, then it's not in Marlin yet. It also could be in Clipper. The other thing is you can go to pins, and you can actually find your processor. Like, I think this is the Octopus. Excuse me. So if you look at like the Pro, you can see there's only a couple pins here that they're showing you down here. So this is appended to another file, which is going to be your Big Tree Tech Common. So if you go over here and you look for Common, you'll see all the other pins. So all the other pins are here. This is how you can modify the board to take other functionality by changing pins. But these are advanced subjects, so I'm going to kind of avoid those unless I'm doing a video on one specific part of the issue, because the complexity can become very hard to follow. But let's see how the actual printer's coming along here. Let me see if I can change the camera angle. So this is going to be a terrible image, but you can see that we're over halfway through, and the surface looks pretty good actually. That one corner I was worried about, maybe it was just the print head wasn't ready, but it's over in here on the other side was a little loose. And I know you guys love this image because what I need is more light down there. So let me see if I can find something to do actual lighting better real quick here. Let me see if I can change that back. I might have a light. Of course, it's the bottom drawer. There's a bunch of stuff more I want to show you guys, but having the time to sit down and work on it is not always the best. So I do have another light. Let me see if I can turn one of these out for a second. I don't know if this power is going to work. And let me swap cameras. I know this is not great. So now you can actually see what's going on. Now you can see that it's pretty good. Some of that movement that you're seeing though is from the stepper. Now, it looks like that one corner is rising off. It is not. It's actually on the surface. So it's just an optical illusion having to do with the camera. But I think I printed this as a solid object, which is probably why it's taken forever to print. And let me show you why that is. Sorry, I'll switch to the other camera now. Or I'll switch to the actual, I'll switch to the camera for the moment. And then I'll show you what's going on. So, essentially, the cube inside of here is set to solid, I believe. But let's check the actual fill. So if you type fill, you can see that I have it set to... Oh, that doesn't look like... Oh, I have it set to 100%. So the reason that this is taking so long is normally we do 20%. And then if you slice it, you're going to see the time is 26 minutes. So apologies, but at least now you know where that setting is if you didn't know where it was. 100% fill is what I do when I'm printing something that I think I want to last longer. So there's certain stuff that I put in the recording rig that you can't see. So let me show you what it looks like. So if I were to switch to this camera and show you, there's something on the rig so that you can hear me better that I put right here. That's 100% fill, and that's probably why the setting is still set to that. So I'm not going to talk about my rig too much for recording, but let's just say that it's going to get more advanced eventually. But for the now, I haven't had time to sit down and actually upgrade it. It will be able to move more magically, we'll say, without me having to adjust it. But let's check the time. See what we got going here. So in Pronterface, it looks like there's 27 more minutes. So I might go and pay the water bill for a second. But as you can see, it's pretty good. Actually, 100% fill in this case might not be a bad idea. Yeah, the SKR Mini E3 is rather cheap. That's what I've upgraded other printers I work with to. And sometimes it's $34-ish, usually during the summers. Their prices go down because they figure nobody's watching or buying over the summer, so the price gets cheaper. But as time goes on, some of these boards will get cheaper, and you can find them also on the used market, but you take your chances when you do that. But let's give this a couple more minutes. I'll be back in a few moments, and you can post your questions and I'll read them off as they're going. And then we'll basically do a quick check of the actual calibration of the printer. And if it's close, I'm just going to leave it and let the person that's going to adopt this printer take care of that issue, because he has already been shown how to do it by me. But I'll point out how to do it for you guys rather quickly. It's similar to the way I tried to calibrate the actual extruder, but the extruder usually should be exact when I do it. But give me a couple minutes, I'll be back, and we'll chat some more. Sorry, the camera went out. Let me bring it back up. So, should be up in a few seconds. There we go. Yeah, Spite Pro, I'd have to look up what the actual board is. Is it a board or a printer for a Spite Pro? Oh, you have an Orbit V2? Let me see what that is. I can spell. Yeah, I'm not exactly sure what an Orbit V2 is. Looks like it's an actual extruder. I'm pulling up the web page right now. Yeah, it's an extruder. So let me see if I can show you guys what I'm looking at. This is an Orbit V2. It looks like it's a stepper, somewhat enclosed. So I don't know how easy it is to work with, but it might be a good extruder. But essentially it's the same thing as what I just installed for the stepper on this printer earlier. But let's go back over and see how that's going. It's getting pretty close, I'm guessing. Let's see what we got for time on it. Looks like 17 more minutes, and then probably about a minute or two to cool off. And then measure, and then it's back to the M503 to find out what the X, Y, and Z are, and then go from there. So it should be pretty simple to figure out. Let's see what we got here for news. News isn't interesting today, but it looks like we got 16 more minutes. So I'll show you what it looks like over here real quick. So this is where we currently are. Can't remember if you can adjust it. No, apparently not. But in some softwares you can actually see the movement of the print head. In here you could probably zoom in and see layer movement, but it's kind of hard to see anything right now, so we're just gonna have to wait, and I'll check on the chat when I move the camera back. So let's see what we got going on in the chat here. Yeah, what you could also do is breadboard the actual connections if you're having trouble soldering, but it looks like you said you don't. Let me see if I can look up a Spite Pro. I don't know what that is. Whoops. Sorry. Well, you're not seeing what I'm doing, so I jumped to the wrong screen, but I don't have it enabled so you can see. Basically just jump through 3 websites. .3D printer. Okay, Spike Pro looks, I guess, like a Creality, if that's what you're saying. But I can't tell for sure. I think it's called an S1 Pro. But if it's similar to the, well, Spike Pro looks like an extruder. Never mind. This one actually looks like it has the motor built in. So let me switch to the camera so you can see. So this is a Spike Pro. It's looks like the extruder sits on top of the actual printer, meaning it's this part right here. And then it looks like there's some kind of cabling coming off and communicates with the board. So it doesn't look complicated. It just looks neater than an Ender 3. But there are ways to neaten up your Ender 3. It's just I usually don't waste my time on it. But let's go back over here. Let me see if I can change the camera to the other one so you can see what's going on. Okay, I'm not lighting it, but I'll let you see what's occurring. So that's where we're at the moment. It's doing pretty good. I'm guessing that we're probably about maybe almost 10 minutes out, because it's almost to the size that we want it. So let's go back to the other camera and watch paint dry. And I'll check on the chat. Yeah, let's see what the time is on this. Yeah, it looks like we got 12 more minutes to go. Essentially, though, it's almost done, or at least 60% of it is, or 70%. And then we'll take out the calipers and see how bad it is. Yeah, essentially an extruder is basically a heating element, a thermistor, and a stepper. So essentially I showed you how to calibrate the stepper, but it's essentially the same stepper that I took out, except it's got a different connection on the top. I could probably use the old one, but I prefer the metal. That's the only reason I changed it. Yeah, you could probably create your own ribbon connectors. There's a tool for it, depending upon what type it is. But like a regular, let me see if I can find one. Right here, these are the easiest ones to make. It's just a vise that comes down and crimps it on. But normally I don't make them because I got too many of them. So I avoid it. And then extruders, there's different ways you can replace them. Normally what I do, well, let me show you one. You can get these for about $2 or $3, but the issue with it is when you drop it in, you might have issues with it coming apart meaning the actual PTFE has to be flush at the bottom, maybe even glued. So what I do is I buy the ones that cost about $12 just because I don't want to futz around with it. So essentially what I do is I get, hang on, I gotta pull it down and untangle all the other cabling in it. I get it like this, and then I disconnect these two pieces and then put it back in with these that are already on it, and then run this back over to here and then call it a day. The only reason I do that is because if I were to replace it from scratch, meaning just the metal part, what ends up occurring is it leaks. So they've taken care of the leaking issue. So it's just $12 in peace of mind versus $3 in aggravation. And you gotta figure that your time costs money, so that's why I do it. Basically it lasts probably 3 times longer than the other one. The other one might last a print. This one will last like 3 months if you do it that way. But these are just tips and tricks that I use all the time. But let me see if I can find the crimping tool for ribbon cables. Okay, here's what it looks like. I'll bring it up so you can see. So for a ribbon cable, it would look like this. So essentially you're going to crimp down on the ribbon like so, and that's all you have to do. Now I don't know if you're using that type of connector, but that's the simplest way to do it. And you don't need to expose it because there's little I don't know if you can see them on these. There's little blades that cut into it. You just have to align it correctly, and it's usually that little arrow. Let's see if I can show you. There's an arrow on one of these. Apparently we're not seeing it. Okay, the arrow is going to be like on one side. It's hard to see on these, but it shows you how to align the cable, so you need to know which side you're on, and then you just crimp down. But there's little metal blades that cut into this that can set it up easy. But let's see how close we are here. Looks like we're 6 minutes out. So I'm probably not going to do a reprint because both you and I might fall asleep if we do that. But it's going to be pretty simple. I'm going to let the end user of the printer actually calibrate it to their liking. But I think it's pretty close. It's probably going to be almost 20 millimeters on each side. And then he can dial it in because he's been trained on how to do it. But I'm also delivering the printer with filament that's going to be cut so that he can put it in himself. He already knows that process, but I'll show you guys real quick. This little thing here you can detach and pull out when you get new filament. Instead of pulling it out, what you'll do is you'll turn on the heater to 200 degrees Celsius, feed in your new filament up to here. This will be disconnected, then push it through to cause it to extrude. Then once you've extruded enough up to probably like there, you'll reattach this cable and you're good to go. That's the best way to avoid issues with your print head. If you pull out your actual filament, you'll create a blob on the inside, which will then cause you more aggravation than you want to deal with. So That's why I'm trying to tell you it's best to keep feeding forward. Once you get into more advanced extruders, like this dual extruder right here, essentially you have 2 inputs and then a reservoir. So this will feed from 2 different extruders into here through the top. I've done a video on it a while back with I think the SKR version 2, and also made mods that I think I put up on Patreon if you want to do that version. Basically you have to print out a little piece up here to hold it, and then there's a shield that is kind of printed with it that'll allow you to work with it with 2 extruders. If you're not experienced in 3D printing though, try not to do it because it might be more aggravation. Let's see where we are here. Looks like we're 3 minutes and 14 seconds out. It's looking a little tall, but then again, my vision versus what the calipers will tell us are 2 different things. But you're going to write down the values. You might want to take multiple readings from top, middle, bottom and average them, depending upon what you want to do, for each of the actual dimensions being X, Y, and Z. But in a second I'll show you how to deal with that. Looks like we're 1.5 minutes-ish out. Hopefully I don't know if I set the end setup on this, but it might be in the actual Cura file. So essentially in the Cura file I set something up so that it spits out the actual bed, but I don't know if I configured it on this one, because I keep changing my configurations because I rarely print at home. But looks like we're down, well, now it says 2 minutes. So it looks like there's 1 layer left after this, but I could be wrong. Yeah, I'm thinking this is the last layer, or second to last layer. No, there's 1 more layer to go, I think. But I can't zoom in enough. I'll show you what I'm talking about in 2 seconds. So over here, you can see that there's, looks like 1 layer left. So that's 1 minute and 14 seconds out. It might be multiple layers, but this will start to turn green if it reaches that portion. So this layer is about to begin. Yeah, so we're at the top layer and it's going to start to fill in. So you can see how it's filling in from that one corner. And then what we'll do is we'll let it cool for a minute or 2, and then we'll take out the calipers after or before that. We'll mark it for X, Y, and Z so we know what we're working with, so we can adjust the dimensions. So the way to do that in here is going to be the M503, and you can see these are the settings we're going to be working with right here, being the M92. You could also do M92 to find it, but it looks like it just completed. So I'll show you this. There's the cube. So I'm going to write on it Z, then I'll write X, and I'm going to write a terrible Y because it's at an angle. And essentially what we're doing is we're going to measure each one of these dimensions so we can set the printer up correctly. So the first thing that we need to do is pop this off when it cools down a little bit. It's probably should cool longer, but because I'm working in a stream, I'm probably going to do things quicker than normal. So, oh, there goes the camera. So here's the caliper. Let me pick the camera up real quick. Okay, so I'm going to pop this off. I'm going to measure the X dimension first. Now this caliper is not super, but it's somewhat zeroed. So what I'll do is I'll do X. You want to try and do this level. So you can see that it's 19.7 right there. But if we go like this, it's 19.6. If we go to the bottom, it's 19.7. So we're going to go with 19.65 or 19.7 as our X value. So I'll write that down. Next I'm going to do the Y. So I'm going to rotate it to the Y, which you can see right here. Do the same thing again. So this one says 20.1, 20.0, so that looks pretty good. 20.1. So we can adjust that. So we're going to say it's 20.05. So Y equals 20.05. Now we'll do Z. So I'm going to turn it. Do the same thing where I measure here. So you can see it like that. It's 19.8. 19.8. 19.8. So we're going to say it's 19.8. So Z is 19.8. So here's what we're going to do. I'm going to turn this off, move it over here. We're going to go over to the computer. We're going to bring up our actual notes, and we're going to say X equals 19.7. Y equals, let's see, 20.05. And then Z equals 19.8. So we're going to multiply each one of these by 5. And the reason we're doing that is so that we make it 100 to make it simpler. So multiply by 5 for each. And we're going to get a value for these. So we'll bring up a calculator. We'll clear it. And then we'll say 19.8 times 5 equals, and that's 99. So that's first dimension for Z. Then we'll do Y, which is going to be, so we'll clear this. This will be 20.05 times 5, which is 102.5. Then we'll do it again for the X, which is 19.7 times 5. And that gives us 98.5. So now that we have these values, this is the actuals, and these are the expected up here. So we're going to say clear for the X. We're going to say that this is going to be, so we're going to say 98.5 divided by 80 equals, then we're going to say multiply it by 100, and that's our new value. Now hopefully I'm doing this correct. That seems a little bit off. I might be doing this equation backwards, so let's try this. We're going to do 80 divided by 98.5 equals, okay, so maybe I'm doing this backwards. So then it's multiplied by 100, and that's closer to what we're looking for. So this is going to be our new value. Apparently it's been a while since I've done this. I'm going to round up to 0.2. We're going to do the same thing here. So we're going to clear it. We're going to say the value is 80 divided by 102.5. Then we're going to multiply by 100. And so it's going to be this value. And then we're going to round up because this one had an 8 at the next digit. Then we'll do it again. And this is why my values probably were off earlier. So this one we're going to take 400. 400 divide by 99. I'm sorry, yeah, that's correct. Then multiply by 100. Excuse me. So that's 404. So these are our new values. So we're going to stick this one here. This one here. And this one here. Okay, so all we have to do is copy this line, go back over to Pronterface, hit Control V, and then enter. Then what we're going to do is we're going to update those values with the M500, hit enter, and now when we power cycle, those values in theory will be correct, but we can check them real quick. So right now you can see the values are right, hang on a second, I'm having a little bit of blindness here. There they are. So those are the new values. Let's power cycle and see what happens. So I'm going to turn it off. Disconnect the Ethernet, or excuse me, the serial connection. Reconnect the serial connection. So you're not seeing what I'm doing, but let me show you. So I disconnected this and powered it off. Now I'm going to reconnect this. Oop, you're still not seeing what I'm doing. Sorry, give me a second. There we go. So this is disconnected and the power's off. Now I'm going to reconnect the Ethernet, or excuse me, serial. Then I'm going to go back over to the desktop. I can technically connect right now because it's got 5 volts power, so I'll click disconnect, connect. I'll do the M503 again. If it connects, connect. It's not connecting, so let me power it up. Okay, I powered up the printer. Let's try connect. Okay, maybe the Ethernet's not fully in. So let me connect it. There we go. So let's hit enter. And our values should be in here. It's going to take me a second because apparently it's hard to read. There they are. So we're all good. So we've calibrated the printer, allegedly. We do another cube print just to verify, but that's the process for getting everything tied up. Nice and easy. And the next stage for this is if you want to check for wicking, you would print something with like 2 posts and then a mid-air print. And what you can do then is if you see wicking, you can control that in here, and I'll show you. Inside Cura, there is, I think, a retraction value. So retraction distance, you can increase this or decrease this depending upon if it's wicking, you want to increase the number. If it's not wicking, then don't change the value. But obviously my default value I think was 3 originally, but then I moved it all the way up to 6.5. So I'll check questions real quick here. Hang on, I gotta turn the camera back on. Lovely. There we go. And let's see what we got for questions. Looks like we're let's see, when it comes to 3D printing, it was my thing. It's covered by something on my side. So let me see if I can just hit something. Oh, it's not getting out of the way. So apparently in the way that I'm seeing the screen, it's covering part of what I'm reading. But I'm thinking it says would, there we go. Would the SKR be better option for the quality? With the SKR 3 or 2, you have to modify the actual connection down below, being the board down here. So this will change form factor wise. If you go with the E3 type boards, then those just drop in as replacements and you don't have to worry about changing the box. But you can always go to Thingiverse and pull the box. Also, the 4.2.7 will drop in as a replacement as well. Yeah, for newer boards with the newer steppers, you won't hear the actual movement of the printer. What you'll hear is the actual fans, and that's about it, because the movement won't be hearable. I have other printers in the other room that are set that way, but currently this one isn't. Maybe in another video I'll show you guys how to do that. It's not hard, but as you can see, what I was concerned with when I replaced this printer was I was feeling this little catching point here, but apparently it's not an issue because it's in the center. So examining this cube, I don't see any real issues with it. So this printer is good to go for my friend, and he'll be happy with it at least for the next year or two. And then he also knows how to do maintenance on it, so he should be good. But let me go back and check that one calculation that we did earlier. I want to see how far off I was. So let me change the screen back over here because this is kind of bothering me. So you remember when we said that it was, what was it, 96 when this was 93? So let's do the calculation again. So let me bring up the calculator. So we're going to do 96 divided by, and no, that was the value we started with, sorry. So it was 93 divided by 96 was the actual. So the value was, if we multiply by 100, looks like this is the exact value. So when I guessed up here for 97, the actual value was this. So at least you can see how I guessed, and we can fix that real quick. So that's the actual value. So let me copy this line and drop it in, and that way at least he'll be exact for the amount of filament he's using. So to save it, we have to do an M500. And that printer is good to go. So I will be working on other printers. I have a new one in the other room and another one hopefully coming, depending upon the person that wants to sell it. And hopefully we can take, I believe it's the version that I worked with originally. This printer was technically a Ender 3. It wasn't an Ender 3 V2. All the upgrades I did made it an Ender 3 V2, meaning I changed, let's see, the bed. That's mostly what an Ender 3 V2 is. I did change the springs, which is an additional change, and the extruder. If on the Ender 3 V2, I believe this part comes off. So the V1, it's soldered on or it's Loctited on. When I tried to heat it, it wouldn't come off. So obviously, it's not something you want to replace if you don't have to. You just drop in your metal over it, and hopefully it is aligned correctly. If not, then you can always spend the $12, $13 to replace the stepper. But the reason I'm doing is it just to show you guys other ways to update. But as you can tell, I'm starting to stutter because it's getting a little bit late. So everyone that's been dropping super chats and PayPal stuff and buy me a cup of coffee, thank you very much. And maybe we'll do this again next week. Maybe Friday or Saturday or maybe Sunday. But I'm probably going to do it, if it's Friday, it'll probably be in the afternoon. Probably around like 2, 3 o'clock. So everyone take care, be safe, and I'll talk to you later.